Hi guys, welcome to my channel. Today let's solve yet another Leet code question. The description of question is as follows that we were given an n soldier standing in a line. Each soldier is assigned a unique rating value. We need to choose three soldiers with index I, J, K with a rating, and a team is valid if first soldier's rating is lesser than second, which is lesser than third, or first soldier's rating is greater than second, which is greater than third. So we need to return the number of teams that we can form with the given conditions. And soldiers can be part of multiple teams. That's all right. Now let's deep dive into the first example that's provided over here. The example is fairly simple. So it's 2, 5, 3, 4, 1. And we need to find the number of teams that are valid. So first I'll check only with this condition that rating of I should be less than rating of J and rating of J is less than rating of K. So I'll call it condition 1 only. And if I consider condition 1, then what elements are possible? 2, 3, 4. Because greater than 2, there are 5 or 3 or 4. But greater than 5, there's no element. So with 5, there won't be any case possible. Greater than 2, if I consider 3, then greater than 3, there's other element 4. So 2, 3, 4 is possible for condition 1. No more pairs are possible, or I couldn't call it a pair. No more triplets are possible with condition 1. If I check condition 2, then if I consider 5, lesser than 5, there's element 3, and lesser than 3, there's element 1. Similarly, if I consider 5, then lesser than 5, there's an element 4, and lesser than 4, there's an element 1. So the triplets formed over here would be 2, 3, 4, 5, 3, 1, 5, 4, 1. And that's good enough. Now let's deep dive into the solution. So instead of solving it as a triplet, I will solve it as a doublet. What would be the advantage for that is, so here if I consider triplet, then n length is 10 cube, and n cube, how much it would be? N cube, so it would be 10 cube whole cube, and it would be 10 power 9. But if I solve it as doublet, then the complexity would be 10 power 6, and I need to solve it as two doublets because one doublet won't be possible. So I'll solve it as this pair and then this pair. I'll tell you the intuition how I'll do that. Then it would be into 2. It's obviously much lesser than 10 to the power of 9, and it would be within our complexity itself, which would be accepted. So I'll do that. So how I'll do this is simple. See, for this triplet to satisfy, independent of this element lesser than 4, there need to be one element, right? That's 3, obviously, prior to the 4. But lesser than 3 also, there should be one element, that is 2. So what I'll do is here, first of all, I'll maintain smallest and largest elements to the left and right side of it. Smallest numbers and largest numbers. So given the rating is, let me do this. Rating given is 2, 3, 5, 4, 1. The smallest to the left side numbers, I'll compute this. So smallest to the left side of 2 is 0, smallest to the left side of 5 is 1, 3 is 1, 4 is 1, 1 is 4. For 4 it would be 2, right? For 3 it's only 1, for 4 it would be 2 and 3. For 1, how many smallest elements are there to the left of it? It's 0. For largest, how many elements are largest to the left side of 2? 0. Right side of 2, 0. Right side of 3, 1. 1. To the left side of 1, 4 largest elements are there. So here I am computing pairwise. So to the left side of 5, how many smallest elements are there? 1 smallest element. To the left side of 3, how many smallest elements are there? 1. To the left side of 4, how many smallest elements are there? 3 and 2, 2. To the left side of 1, how many smallest elements are there? 0. So first let me compute this, and then I'll explain you the second half. Smallest, and it would be n initialized with 0. So I need to define n as well, and n here would be rating dot size. I'm sorry, vector in largest n with 0. I'll traverse through the complete ratings vector, and I'll also check all the prior elements until 0th index, and I'll check if rating of I is greater than rating of J, then the number of smallest elements to the left side of I will be increased by 1. Smallest at the index I would be increased by 1. Similarly, if the rating of I is less than rating of j, my largest of I would be incremented by 1. So let's check this out. First, let me return some dummy value for debugging purpose. Let's check out if our smallest and largest vectors are same as what we thought. See what is less than only. And finally, I'll have a new line after this, and I'll also print the largest numbers. So the result for the first case should be 0, 1112, 0, 0, 0, 1114. It's correct. So we have this smallest and largest vectors. Now what I'll do is see. I do have the smallest and largest vectors, and what I'll do is now I'll check to the left side of 4 the number of smallest elements that are left side smaller than it. So left side of 4 there are two elements that are smaller than it, 3 and 2. So if I consider 4 as a current index to the left side of 4, if I consider 2 and 4, but to the left side of 2 I am specifying that there are 0 smallest elements that are lesser than 2. So it won't be a possible triplet. And to the left side of 4, if I consider 3, then 3 will be fixed, 4 will be fixed. To the left side of 3, I am specifying that x elements are smaller than 3. That x can be anything, but now I am specifying it as x. And here x is 1. So number of triplets that can be formed with the help of this two having the last two places is 1. In the similar way, if I consider the largest case, here I am specifying that now to the left side of 5, I am specifying that there are 0 greater elements. No, first let me check this out. So first I'll consider this 3 and 5, but to the left side of 5, I am specifying that there are 0 greater elements. So to the left side of 5 there are 0 greater elements, so this won't be a possible triplet. And to the left side of 4 as well, 5 is greater than 4. So I'm fixing this 5 and 4, but to the left side of 5 there are 0 greater elements that are greater than 5. So this won't be a possible triplet. Now let's come to the one case. If I consider 3, 1, and I'm specifying that to the left side of 3 there is one greater than element, that's x, considered to be x, and x here is 1. So this will give us one pair. Again, this will give us one pair. That x could be anything. Similarly, if I consider 1 along with 4, I am specifying that earlier to prior to 4 also there is one greater than element. So here it would be x again. So this would also add to one pair. So how many pairs are we getting? 3 pairs. That's almost, no, not almost, we are already ready with our answer. So I'll do just what I written over here. So and I is less than 0, I is less than n, I plus plus. I need to check the number of elements that are smaller than 4 or smaller than 3. So I need to traverse from the element with the left index of it, and I'll need to check all the elements to the left part of it. Same exactly what we done earlier. So I'll check if rating of I is greater than rating of j. That would be the case over here. So I'm checking if 3 or 4 is greater than 3. Then what I'm doing is simply I'm adding out all the smallest elements that are present to the left side of 3. Got it? Here we assumed earlier that there are x elements that are smaller than 3 and x is 1. So I'm adding small number of smallest elements to the left part of j. Same exactly. I'm checking if rating of I is less than rating of j. That's the condition over here. 1 is less than 3 if I is at last index and j is at index 2, then I'm checking the number of elements that are larger than the jth index, and that would be added to answer. This suffices my condition 2 and condition 3. So I'll just simply return answer and this should work fine. Nice, it's working fine. Just add anything in the comment section if you feel anything is confusing. Thank you.